All right. Hello there. Happy Monday to you. All right, friends. So today we're going to take the work that we've been doing over this last week with actually just a few days with area of a parallelogram, what you already know about rectangles, and then area of triangles. And we're going to combine those into what we call complex figures, right? So a shape that is maybe made up or created by putting some other shapes together. I'm going to walk through this one with you. And then I'm giving them all to you on draw slides so that you can draw the lines to mark them up. I wish we had a book. We don't have the sixth grade math books. Like even if you were in class, we don't have the sixth grade math books. So the best I can do for you is to have them as a draw slide so that you can draw the lines and break the figures apart on the screen while you're working. Okay, so we're going to work through this one together, and then I'm going to give you a few. They take a while, so I'm not giving you a ton of problems today. Here we go. A costume designer is making a superhero costume for a movie. The costume will have a logo on the front. The designer draws a plan for the logo on 1-inch grid paper. What is the area of the logo in the drawing? All right. Superhero, boom, right, with the big like S through the middle there. All right, so when I take a look at this shape, I don't know, I don't have a formula for area of something like this. And I'm sorry, you guys, if I was saying volume earlier, I'm really sorry. I'm sorry. Anyways, area. I don't know the formula for the area of this like wonky diamond shape, right? But what I can do is I can start drawing some lines and creating shapes I do know how to find the area of, right? So there's no one right way and wrong way to do this. In fact, there's a few ways you could do this. I'm going to start by drawing this line here so that I create a triangle on the bottom. I could find the area of that triangle by going base, let me do this. Base times the height, right? That's where those perpendicular meet. So this would be the height. I'm just going to count the squares. Base times the height and then dividing that by 2. Now I've still got this part on the top. There's a couple of ways I could break that up. I could make 2 little triangles on the side and get a rectangle in the middle. Now I've got 4 shapes to find the area of, or I could make a parallelogram by doing this and find the area of this shape here, plus this little triangle, plus this big triangle, right? That's one option. Another way that I looked at earlier that I thought, oh, this would work is I could have broken it up like this, right? You see those lines? Oh, sorry, blue's maybe not the best color. I could have broken it up like this. So I would have these 2 smaller triangles on the side, this triangle down here, and then a rectangle in the middle. Okay, there's no one wrong way or right way to do it. It's just once you find a way to decompose or break that shape apart into triangles, rectangles, parallelograms, things we know how to find the area of, then you find the area of all those smaller ones, add them all together to find the area, to come up with the area of the whole shape. Okay. All right. I'm giving you, I think, 3-ish of these problems because they just take a little while to do. And in fact, on one of them, I'm just going to ask you to draw lines, right? I'm not going to ask you to find the area, but draw lines to decompose it into shapes that you would know how to find. And then I'll give you 3 where you're finding the actual area. Oh, sorry. And don't forget our formulas. Rectangle, length times width, parallelogram, base times height, triangle, base times height divided by 2.